Now that we have already discussed Coulomb's law, let's try to solve problems on Coulomb's law. Let's have the first problem. 2-point charges are placed 0.3 meters apart. The first charge is positive 4 microcoulomb and the second charge is negative 6 microcoulomb. Calculate the magnitude between these two charges. So let's say this is our illustration of problem. We have your Q, which is positive 4 microcoulomb. The other is Q, your smaller Q, which is negative 6 microcoulomb. Let's consider the two decimal places in our given values. And the distance between them is 0.300 meters. So what we're going to find out is kung ano ang kanyang electrostatic force. So before we proceed, of course, this is in microcoulomb. Therefore, kailangan natin i-convert yung ating mga values and we must convert it into its SI unit. And the SI unit of charge is in coulomb. So if that is microcoulomb, now 1 microcoulomb is equal to 10 raised to negative 6 coulomb. So therefore, from that we can get Q is equal to positive 4.00 times 10 raised to negative 6 coulomb. The other, your smaller Q or the other charge, then Q is equal to negative 6.00 times 10 raised to negative 6 coulomb. And the distance between them, R, is equal to 0.300 meters. Now I have the formula F. F is equal to K times Q over R squared. Now let's substitute the values. So that is F is equal to K, which is 8.99 times 10 raised to 9, sorry, that's 9, times Q, which is positive 4, sorry, that's positive 4, positive 4.00 times 10 raised to negative 6 times negative 6 times 10 raised to negative 6 divided by 0.300 squared. Now if we're going to round this, okay, so one way to solve this would be just without using your calculator, you can actually solve this. We have 4 times negative 6. Let's put this as 9 already. Okay, you may just write this as 9. So 9 times 10 raised to 9 times, now 4 times negative 6 is negative 24 times 10 raised to negative 12. And here, if we're going to put this, write this in scientific notation, this is actually 3 times, this is 3 times 10 raised to negative 1. And we're going to square that. 3 times 3 is equal to 9 times 10 raised to negative 1 times 3 is negative. And then we can actually cancel this. Then we have F is equal to 10 raised to 9 times 24 times 10 raised to negative 12 over your 10 raised to negative 2 is not yet cancelled, sorry for that. So this is 10 raised to negative 2. And then 12, negative 12 minus 2, this is negative, sorry. So 12 minus 2, we have now 10 raised to 9. And then we have times negative 24 times 10 raised to, if we subtract this, negative 12 plus minus negative 2 is equal to negative 10. And then we subtract that, we have 10 raised to 9 times 10 raised to negative 10 is just 10 raised to negative 1. So f is equal to negative 2.4 at negative 24, sorry. It's negative 24. That negative 24 times 10 raised to negative 1. And that is, f is negative 2.4 Newton. So the force between the charges, since these are positive and negative charges, then it's an attractive force. Therefore, the force is negative, and the magnitude of that is 2.4 newtons. And that is our first example. Now we proceed to the second example. Let's have your second example. The electrostatic force between two charges is 10 newton. One charge is 2 microcoulomb and the distance between them is 0.5 meters. What is the magnitude of the second charge? So let's list our given values. So we have our force, or the electrostatic force between the charges is 10. It's positive. Therefore, we can conclude that these are same charges. So if this is positive 2, then the other should also be positive. But we do not know yet the magnitude of the second charge. So F is equal to 10 Newton. The distance is equal to 0.5 meters. And then we have the charge Q is, let's convert that already, 2.00 times 10 raised to negative 6 Coulomb. Okay. Now, what is being asked in the problem is the magnitude of the second charge, or the other Q, yung hinahanap natin, yung isang Q natin, or charge. So, we have your formula F is equal to K times Q times the small q over R squared. So, anong gagawin natin? We just derive an equation for Q. So, what we need to do is multiply both sides by R squared. So, para matanggal natin itong R squared dito sa baba. So, we can cancel this. And then, ano pa kailangan na cancel? Yung K and Q. So, we multiply both sides by the reciprocal of that, K and Q. So, K and Q. So, cancel natin ito. Therefore, we have our formula Q, or the smaller Q, is equal to F times R squared over K times Q. And that is now our formula for Q. Now, solving for Q, so let's just substitute. Mag-substitute na tayo ng ating values. Q is equal to F, which is 10 newtons. So, using that, 10 newtons. So, we have 10.0 times the distance between them is 0.5 squared divided by K, which is 8.99 times 10 raised to 9 times Q, or the first charge, it's 2.00 times 10 raised to negative 6. Okay, simplify. We have Q is equal to, this is 0.25 times 10. That's 0.25. This is 0.5 times 0.5 is 0.25. Now, 0.25 times 10 is 2.5 over 9 times 2 is already 18. 18 times 10 raised to, this is 9, this is equal to 3. Okay, so what is Q? So 2.5 divided by 18,000 is equal to 1.39. So it's 1.39 times 10 raised to negative 4 Coulomb. Therefore, the magnitude of the second charge is 1.39 times 10 raised to negative 4 Coulomb. And that is the answer to our problem. Let us now proceed to the last problem that we're going to discuss today. So let me just put this here. Lipat lang natin siya sa baba para makita natin. Okay, so we have okay, 2-point charges, positive 6 microcoulomb and negative 2 microcoulomb exert a force of 12 Newton on each other. What is the distance between them? This time, what we're going to solve is R. So, listing our given values, Q, or the first charge is 6.00 times 10 raised to negative 6 Coulomb. The second charge, Q, is equal to negative 2.00 times 10 raised to negative 6 Coulomb. And then the electrostatic force between them is 12.0 newtons. Now, solving for that. Okay, let's now solve for this. What is being asked is so from our formula, F is equal to K times Q over R squared. So multiply both sides by R squared, and then divide both sides by F for you to remove that F. Okay. So remove that F, and then R squared is also removed here. Therefore, we have R squared is equal to K times Q over F. And then we extract the root of both sides. Therefore, we have our formula R is equal to the square root of K times Q times the small q over F. And that is now our formula for the distance between the charges. Now, solving for that, R is equal to the square root of 8.99 times 10 raised to 9 times the charge, the first charge, 6.00 times 10 raised to negative 6. Now, for the second charge, we will remove your negative sign because that will result to a negative value. Actually, if they are positive and negative, then this must be a negative value. So this must be a negative value. So that will be negative 12 because it's an attractive force. I forgot to mention. Okay. Next, we have the other charge is negative 2.00 times 10 raised to negative 6. And then divided by the electrostatic force between them, which is negative 12 newtons. So R, putting that in your calculator, so let's just try to solve this. Square root of 8.99 times 10 raised to 9 times 6 times 10 raised to negative 6 times negative 2 times 10 raised to negative 6, and then we divide that by negative 12, and the answer is okay, 0.948. It's 0.0948 meters, or that is actually 9.48 centimeters. So the answer is 9.48 centimeters. So the distance between the charges is equal to 9.48 centimeters. So that is how we solve, that is how we apply Coulomb's law for 2-point charges. I hope you have learned something new for today, and I'll see you on our next lessons.